Hello everyone and welcome to Network Forensics. What are your investigations missing? I'm Jason Keeler with the SANS Institute and I will be moderating this webcast. Today's featured speaker is Philip Hagan with Lowe's Technology Consulting. Before I turn things over to Philip, the Q&A portion will take place at the end of the webcast. Please feel free to submit your questions at any point by using the chat window. Right now I'd like to introduce our featured speaker, Philip Hagan.
Hello everyone, glad to be here, and it's good to see a couple of good familiar names on the list. I hope we've got a good program put together for you. I'm just going to go ahead and start sharing my screen. All right, looks like that's coming up well. All right, well, as mentioned earlier, this is Network Forensics. What are your investigations missing? I'm currently coming to you from a pretty cloudy day out here in southern Delaware. Hopefully it's a little bit better weather where you might be. Let me go over real briefly what my goals are for this presentation. First of all, this is going to be a brief primer on network forensics. We're not going to be able to get too deep in an hour, but I think it'll definitely be enough to try and get you interested and kind of show where network forensics is going. One of the areas that I do like to focus on is where are the existing sources of evidence that can help on a network-based investigation or any investigation that involves the network, not just a network-based one. And where are those pieces of information that you might be able to use. I have a couple of real-world examples where network forensics helps complete a picture in real investigations, and hope that those will drive home a few of the points I've got. And I really want to look ahead to the next 3 to 5 years, maybe, even if that long, to see how I foresee network forensics becoming a more core part of our practice. And of course, really just want to get you interested in the topic. It's something that I work with very, very frequently, and I really do enjoy it, and hope that it spurs enough interest to maybe have you learn some more. Maybe come see me in one of the upcoming network forensics classes, or if nothing else, maybe ideally just improve your day-to-day work that you're doing in your work, your personal research. Just so that I'm not completely a disembodied voice at the other end of the internet, just a little background on myself. I'm an Air Force Academy graduate, class of 1998. I was computer science major there. First got interested in information security at that point. Really had no existing community. Information security was still this thing that people talked about in very hushed tones, and it was just emerging into something of its own. After I graduated, went into active duty. I was an Air Force communications officer, worked at 2 assignments. I was in Beale Air Force Base in Northern California, and then transferred over to the Pentagon, where I was responsible for some practitioner type information security, I would call it. We were on a very vulnerable network at the time, and had to field some pretty unique requirements. So it was something that really showed me the real world application of information security, and how difficult it is to balance user requirements versus reporting and security requirements. In 2003, shifted out of the Air Force, became a contractor, worked with, actually that's where I recognize a bunch of the names from the list of folks in the webcast today. And got to do some pretty fascinating work there, including working with Rob Lee, with a couple other folks in the room today. And eventually wound up managing the computer forensic practice there. We had about 85 folks and a lot of the government labs in the greater DC area, and some other locations around the world, and really kind of brought home a lot of what I'd learned at that point, and kind of made it a lot more real. It was a lot more comprehensive practice than I had worked in previously. Since then, I have transferred off to become an independent consultant, and primarily working with computer forensic and information security consulting at this point. A lot of the work is federal law enforcement, and then also working a bit in the commercial side as well. And I've since begun to work with community SANS. I do currently teach Forensics 558, our network forensics course, and I've got one of those coming up in community soon here in a couple of weeks. So maybe there's a chance we can get a few of you to come down to Quantico, Virginia, and I've got the dates coming up later on when that is. All right, so the obligatory brief computer forensics history slide. Back originally, of course, we saw dead box forensics. Find a system that was involved in an investigation somehow or relevant to an investigation, pull a hard drive, preserve the evidence, work on working copies, and at that point you produced a report and you moved on to the next phase. It was very very difficult to handle anything dynamic because the practice was focused on data at rest. Well, then we moved into the memory forensics era, which is obviously in full swing now. There's so much great work going with like the month of volatility plugins this month and so much other research and real-world products coming out to help in that regard. But we finally had to adapt to the fact that data may change. And this was a pretty radical thing for the community to deal with at the time because, well, what do you mean that you can't collect the evidence without changing the evidence? When you run this memory dumping utility, you're going to have evidence of the memory dumping utility in the evidence. It's this circular logic that people really had a hard time with. That's something that we've just finally begun to get our brains around collectively as a community, and be able to incorporate live response and similar type of evidence into our investigations. Well, then we move into what I would say is the current evolution of this process, and we're incorporating network forensics. And network forensics is also something that is very dynamic, obviously, but it's such that if you don't catch that packet as it's crossing the wire, or if you don't catch that piece of network evidence, you're going to be in a situation where you don't have, quote-unquote, all the evidence, and that is really something that we are struggling with. You can't very well serve a router with a subpoena or with a preservation of evidence request and say, please keep all those packets that you passed last week while I go get a warrant. That's obviously never going to happen. So we need to adapt our practices to derive benefit from the network-based evidence. But at the same time, we also need to be realistic and understand that we're not going to get every single bite and be able to explain why that happens and how that happens. Now, obviously, who knows what the future is going to hold. Maybe it's going to have time machine forensics. So if anybody here has taken a forensic image of a DeLorean, please let me know. I'd be very interested to hear exactly how that went and what you processed it with, so we can work with Rob and get that handled in the next version of the SIP workstation, I guess. But through all this, the one constant has been a need to adapt. We need to accommodate all these new sources of evidence as they come into widespread use and widespread, seeing them out in the wild. And we need to incorporate them into our approach, because very seldom do we have a situation where, hey, we can do memory now, so we don't do dead box forensics. We don't look at the hard drive anymore. Oh, we can do network now. We don't have to do anything. That's ludicrous. We're never going to do something like that. Instead, we want to use all these new sources of evidence and all the new research and capabilities to better complete our picture and provide a more comprehensive understanding of an incident that we may be investigating. And a real key example that I love to use for this is a paper that Jesse Kronblum put out in 2006, which is ancient history in the computer forensic world, but it was called Using Every Part of the Buffalo. And even in 2006, try to think back to where memory forensics was at the time. And memory forensics was very nascent. We weren't really talking about it at conferences even. But even then, Jesse's paper said, hey, look, if you're using memory forensics, that's great. But here are some things that you're not yet using, you're not incorporating, you're overlooking. So we're seeing this cycle speed up and speed up. And that's the point that I want to make, is that the only constant we're going to see is that things are going to continue to change. And it's probably going to get even faster. So the better we are able to adapt our processes to handle these new sources, the better off we'll be in the long run, of course. So just a real brief look on what I see in the network horizon right now, what's in the 6-month window or current even. Primarily, we're seeing the network used increasingly for core functions of an operating system or of software. Software installation and updates, hey, that's old hat, right? We've been doing that since the WSUS server was a thing back in the early 2000s, early to mid 2000s. But what we're seeing now is this concept of, for example, slipstreamed updates. We are seeing Chrome, which I think is the model that a lot of these software vendors are going to move to, that just silently in the background downloads its updates, starts applying patches when it can, and if it needs to restart, it just gives you the little warning and says, okay, it's time to go. We're seeing that to an extent in Windows, but the Windows operating system, but I definitely foresee the Chrome model of this slipstreamed background updating where you don't even know it's happening. That's going to become more common. And as far as installations go, the Mac App Store and all these various application download centers that the platforms are employing now is becoming pretty common. Offsite sync and backup, I hope everybody is familiar or at least heard of this Dropbox service, kind of the darling out of the Y Combinator startup world in Silicon Valley. They're that type of service that's being able to let you synchronize your documents across multiple platforms, multiple systems simultaneously. That is something I foresee becoming integrated more into an operating system. We're seeing backup as well, where it's offsiting your backups in near real time. I use a backup service that I don't think I've looked at it in 2 months because I know it will yell at me if it doesn't work, and I know that it's backing up everything that's important to me. Background API activity is something that I consider pretty fascinating. API, application programming interface, if you're not familiar with it, it's essentially a set of rules and protocols for machine-to-machine communication. So it's how one piece of software interacts with another piece of software. Well, as we see some of these so-called cloud-type services and all these other hosted platforms out there, looking into the next bullet, everything is a service. You know, these services have to interact with the software on a client system, and they do that through these APIs. I saw a figure that said somewhere north of 51% of all internet traffic is currently non-human generated, and the vast overwhelming majority of that is derived from or directly the result of these API calls that are happening. I've got a couple examples of how that works coming up in a bit too. I mentioned everything as a service. This has become more of a marketing buzzword, I guess, than anything else. You've got your software as a service, your platform as a service, infrastructure as a service, everything as a service. And those are all a result of the centralizing of computing resources, whether that is something like an Amazon EC2 or Rackspace's type of solution. You're able to offsite a vast majority of your functionality, but of course all these services are fundamentally relying upon the network to communicate, to manage themselves, and certainly at the end to provide data or information wherever it's needed. Now, despite all these brand new, fascinating, sexy things that you can use the network for, it's still good for the old standbys. Malware's got to talk. Malware's got to beacon out to its command and control server. When the network is compromised, it's compromised for a reason, and it's probably to watch or collect or extract information from that target network. And generally that's happening over some kind of a network link. You don't really see too many crazy Hollywood transfer stuff over the air through these exotic interfaces when the network is there and it works. And probably one of my favorites is bad people still talk about bad stuff because, hey man, there's dumb bad guys out there, and the more of them we can wrap up because they like to talk about the things they do over email or instant message or any of these other protocols, the better. One case in point, case that I have been able to support for a while now. We had someone who, for some reason, archived about 4 to 6 years of their instant messages on their own system. So we had 190-some thousand instant messages that we could go through. Now in that case, of course, we were pulling that off of a disk, but it just shows that there's really no slowing down in the rate that bad guys are willing to talk and communicate, collaborate over open network links. So there's I'll call it two main ways to acquire network data. And the one that most people think of right off the bat is live capture on the wire. This is going to be stored usually in a PCAP format, if you're familiar with that term. The utility TCP dump is what's most often used to collect it. If you're in a GUI environment, you can use what's called Wireshark. Some of these utilities may be familiar to you. If not, certainly things that you can dive into, generally free utilities. But when capturing data on the wire, there are two primary modes of operation, I would call it. One is to collect headers only, and one is to collect full content. Now, if there's any folks in the room that are law enforcement or have a law enforcement background, the header capture is analogous to a pen register or a track and trace device. That's the sample that you see in the little blue box down below. And that is just going to be the metadata about the packet. So if you look at this packet, I'm pretty sure, yeah, you can see my cursor. You're going to see a source IP address, a source port, a destination IP address and port, and there's a couple other bits of information that are embedded in here according to the IP protocol. And in this case, what you would find if you were to decode all that is this is a UDP port 53 packet. And that's all that we can tell at this point. Is there anybody that should be familiar with most network communications? You may be quick to think, well, hey, that's DNS. And that's not really a bad guess. However, because we only have the headers, we don't know. All we can truly say, all we can observe is a source IP and port, a destination IP and port, and some other information, including the length of the packet that was originally on the wire versus what was just captured in this header, and a few other pieces of data. However, once we transition into a full content capture, you see that it adds on the boldface fields here. This, in the law enforcement analogy, is a Title III or a wiretap. So this is when you're getting the entire packet. And what we see here is by parsing out this information, we see that truly this is consistent with a DNS query. And this DNS query is for the A record associated with the host name CNN.com. Is the full content in this case more helpful, more expensive? Oh, absolutely. There's no doubt about that. However, I want to be really careful to avoid the pitfall of saying that header data alone is not worthwhile. Header data can be extremely, extremely valuable, especially when it's all you have. Aside from the procedural difficulties sometimes of being allowed to capture full content or put a wiretap in place, the amount of storage required is huge, and there's a lot of other potential drawbacks. There's the potential for lost data on full content capture. However, what I'll say on being able to capture header data is a little bit of real-world information, real-world case study, so to speak. I had a situation where a large number of systems around the world were backing up their data via FTP to one system. We identified that system, and we were looking at the headers. We had a pen register up on that FTP target. By looking just at the headers, we were able to map out the entire architecture worldwide of where all these systems were and what their backup schedule was, roughly how much data each one was backing up. And through some other analytic insight that we had, we were able to characterize what kind of activity each of those remote systems around the world was responsible for within this global architecture. It was very, very successful, and there are some other big successes that we had out of that pen register that was up, and we would have never been able to get a Title III or a wiretap approved in that case. So just having the headers was wildly successful. So even though full content is great, it certainly does have its drawbacks, and a lot of times headers can get you what you need. So the second way to acquire network-based evidence to support an investigation is actually not often thought of as collecting network data. But we're talking about logs from services and infrastructure items that assist with or facilitate network transfer. So for example, if we're looking at proxy servers, a web proxy server logs every URL that the systems behind it are requesting. Well, that's a very valuable piece of evidence. It can be, I might even say, invaluable, depending on what the aims of the investigation are. But that's something that should never be overlooked. Firewalls may, in some cases, keep packet logs. Probably in most cases, I would say they would be logging packets that are denied, which can be useful. But I've even seen some organizations that logged every packet that was successful. It got a little bit excessive, to say the least. But you know, in the case that we were working at the time, it was all we had to go on, and it was very helpful to look back into their archival past. Flow records, if there's anyone in the webcast today who's familiar with you know, network architectures and things like that, setting up large networks often involves logging what's called traffic flow, and that's going to just be a very, very high-level accounting of how much data flows from point A to point B or link A to link B. It's something that most network admins will use to determine, is my network link saturated? You know, is there a vast migration of data between portions of my network? So it's usually used for an administrative purpose. However, it can be very valuable to us if we're looking at was there a large cross flow of information between the production net and the executive's subnet, for example, or a large transfer of data from a set of servers to an offsite link that they really shouldn't be going to. You know, that can certainly be useful to us in trying to hone our investigation down. Now, what I love about all these utilities is that they probably exist. So if you're in an incident response role and you walk into a victim organization, you can very reasonably say, hey everybody, can we have all your proxy logs? And they're probably not going to look at you too funny, because that's a very common thing for them to have. I think that not asking for these is doing a disservice to the investigation, to be completely honest, just because they do exist, and tools are readily available to analyze them. Now, kind of jumping outside the mold a little bit, or thinking out of the box rather, there's a lot of new technologies out there, and I see that there's some folks from Carbon Black in the room. You know, I'm not changing what I'm saying here because they're here. I've said this a number of times before. I'm very impressed with the product that they've put together. The analogy that they'll use is it is the security camera for your network, or it is the equivalent to the airline's flight data recorder for your network, and it's almost an agent-based setup where the endpoints on the network will report into a central server all manners of useful information, such as whenever certain files are opened or executables are run, or from a network perspective, whenever a network socket is opened. So we're almost getting firewall level granularity, but we're getting that from the endpoints. So it's when we see cross flow of information between subnets that doesn't cross a firewall, that's something that a firewall log is going to miss. But a utility or something along the lines of Carbon Black, it's collecting all this information in the background, so when you walk into an incident response, if that data is available, it can provide a very, very granular picture of what was happening on the network side of the house in the past, and you don't really have to think too hard about it. You know, so that's just a piece of technology that I've been very impressed to see grow, and I foresee a lot of other interesting out-of-the-box type utilities that will be able to help us as well. Now, this is not a technical thing to look at. We need to consider things that are non-technical as well. I hope for your sanity, nobody has had to walk into a data center that looked like this, but in order to protect the guilty, I will not ask anybody if you've walked into a data center that looks like this, or if you have a data center that looks like this. But one thing that I think is really important is sit down and talk with the network admins. They can help explain what a commented, even the best commented configuration file can't explain, which is why was something done like this? Why was X done? Why was this setting put in place? Why are the logs stored here in this partition versus this other system? Those can all be very, very useful to us as investigators because we can capture the configuration files, we can capture the log files, we can enter them to evidence. But then when you're sitting there looking at it, you can be left with an infinite number of possibilities on why something may have been done the way it was. So let me go back to the concept of augment, not replace. I've put a picture of the U2 up here, not because they fly it out of the base I used to work at in California, but because I think it's a really cool airplane, and I think it's an incredibly good analogy for our approach, what our approach should be. The U2 is a jet that you can essentially build a new configuration depending on the commander's requirements. So for example, commander comes in and says, I need this loiter time of a certain number of hours, and I need it to be looking with these sensors, and I need this other capability, and I need data link in this many minutes or hours or whatever the case may be. And what the people are going to do, the maintainers who are responsible for this airframe, they're going to pretty much build a new jet. It's kind of like watching a Lego set put together, and I don't make that analogy lightly. It's really impressive to see. They will put together all of these different capabilities and build exactly what is needed to address the commander's requirements in the field. In that same vein, I think that we need to continue corroborating our findings. When we look at a dead box analysis, for example, we can refine our understanding of what was happening on that system at a certain time by incorporating the network perspective into our analysis. So a couple of examples of this. PSExec is a utility that Windows can use to remotely launch a command on another system. So if you see evidence of PSExec being used on a Windows system, maybe a victim system that you know or suspect was compromised, that can be a useful observation. That's a good finding. However, if we are then able to use the network side and use a network data source of some kind, we could potentially determine, was that PSExec successful? Did it return data? Did it return a little bit or a lot of data? Is it consistent with an error message, or is it consistent with some other kind of command output? It can be very, very useful there. Let's say that we observe that a sensitive file was accessed, and the proverbial example is, hey, what if we see that the CAD file for the nuclear power plant was accessed? The A time on the file system indicates that it was updated, that A time was updated while we know an attacker was on a box. Well, that's a useful finding again. However, was it extracted from the network? And exfiltrated probably isn't the right word. I'll change that before I PDF these documents. But if, for example, that CAD file was a 3 meg file, and then as soon as it was accessed, we see that there was a 3 meg data transfer from the compromised system to a foreign IP address of some kind, that's going to create a much bigger finding than just, hey, this file was accessed. That, I think, is something that's extremely useful. Excuse me. A case that I did support as well, this was the situation where we saw a large database that was accessed, and then we saw the data leave the building. And we were able to say, hey, the amount of data that left the building is consistent with the attacker's preferred compression utility after it compressed this set of database files. And it was absolutely absolutely incontrovertible proof at that point that we said there's very little chance this is anything other than your whole database walking out the door. Another one that's obviously getting a lot of play is phishing. If we're able to see that a phishing link was clicked, maybe we see that URL show up in someone's email, and then we see that the URL also shows up in the browser history. Again, okay, person clicked or otherwise opened that URL. However, what happened next? Was there a download attempt? Did it try to get an exe file? Was it successful at getting that exe file? If it was successful, that would most likely be something we'd see in the file system forensics. But if it was not, we may see that only in the proxy log. Did the proxy block that for some reason? Did an antivirus solution, inline antivirus, did that potentially flag and deny that? Those are all network-based indicators that would complete our understanding. And then, even more so on that, do we see any kind of a beaconing after that? What if every 60 or 120 seconds after that link was clicked, we see a network connection attempt leaving the network going to a suspected or confirmed malware command and control server? Well, that's going to be a very, very compelling picture that we can paint. I'll mention this one briefly because I've got a real-world example that we're going to step through in just a minute here. But it's search history entry. Of course, when you go to Google and a lot of the other search engines now, when you start typing in your phrase, you're going to see the search results appear in near real time. And the keystroke timing can be a very, very telling indicator on whether or not there is a human at the keyboard or whether it may be a piece of malware. And I'm going to step into that example right now. All right, so this is the venerable search bar. This example comes out of a version of Firefox running within Linux, but it can be pretty much any browser on any platform. Now let's say we've got an individual who's starting to type in this search box, and they type how to. Well, you can see a whole lot of the possibilities that Google thinks they may be looking for. Maybe they really are looking for how to cook spaghetti or how to delete their Facebook account. But in this case, our person that we're looking at is searching for how to dump a body. Now, it doesn't really matter what my investigation is about. I'm going to probably call this interesting. I may not call this a finding if I were to see it, but I would definitely call it something worth looking a little further into. But before this person hits enter, they remember, hey, wait, when I logged on, I had this banner that said that those network guys and girls can look at everything I do on my computer, so I'm not gonna search for that. I'm gonna change my mind. Now, if you've gone through one of the forensic courses or you're familiar with browser forensics, you know that if the user doesn't hit enter here, it's not going to be entered into the search history. It's not going to be entered into the browser history. There's a lot of places where this will not show up. And you may get lucky and find this somewhere in, for example, memory or some other type of structure. But those are definitely going to be long shots. And they're not going to be as much of a guarantee as it would be if the user hit enter at this point. So at this point, our user realizes, like I said, this is a bad idea. We're not going to do this. I'm going to go ahead and backspace this out, and instead I'm going to type how to bake a cake. Now, I don't know if anybody here has played Portal, but if you are familiar with the meme, you know that the cake is a lie. There's never a cake. So we know that this user probably wasn't looking for how to bake a cake. But what does when the user hits enter, the browser-based forensics is going to show us that this is all they searched for. But if we go into the network side, now we can see the complete picture. And what you'll see here after that scans down, this is an output from Wireshark. If you're not familiar with it, it's a packet capture and analysis utility. And this is showing every single URL, API URL, that the Firefox web browser was making as the user was typing. Now, if you look over to the side of the red box, you'll see that here's the first query as it was built up, a character or so at a time, and here's where the user backspaced, and then here's where the user typed in their second query. Now, this to me is pretty clearly indicative of, it looks like a keystroke logger. It looks like any kind of a keylogger out there, which is very, very valuable, but it's happening a key at a time over the network. And as long as you understand, know enough to research what the structure of these URLs are that the Firefox browser is sending in the background, you can derive a tremendous amount of investigative value from this kind of information. Now I show, in this slide, I'm showing the example within Wireshark. There's no reason that it couldn't also be something from, this kind of data would come from a proxy server. But you can see here pretty clearly the URLs are telling you a very compelling story. I mentioned on the previous slide keystroke timing. had a situation where we were assisting with a company's investigation of one of their employees. The employee was found to have been conducting inappropriate web activity, and the first response was, "Hey, it wasn't me. It was a virus. I didn't search for that bad stuff. The virus did it." Because anybody ever hear that response before? It's probably one of the most common excuses that I hear. However, the user did have some kind of malware on their system. I don't remember if it was a virus proper, but it was some kind of nasty evil. So we were working on the chicken and egg problem. What came first, the unauthorized activity or the malware that was on the system? And one of the things that we pulled during this investigation was the proxy logs. Now, the proxy logs showed that the individual's system was responsible for activity that was using Google to search for terms that were consistent with the unauthorized activity on their box. But what we did, we had a sufficient enough set of data that we ran some statistical analysis against it. We found that the keystrokes were entered with exactly 1 second apart, plus or minus, I think the standard deviation was 0.01 or 0.02 seconds. It was ridiculously small. So at that point, we took a step back and we said, well, you know what? There's a lot of good typists out in the world there. I am pretty sure that there's no typist that is good enough to type with that degree of regularity. So I think we can characterize that activity as machine originated. And I don't remember what the outcome of that particular investigation was, but we were able to rule that out based on the network data that we had available to us. Okay, one other example that I like to talk about. Everyone should, if you haven't heard Chad Tilbury speak about some of his geolocation artifacts, really impressive. He talks about a lot of the artifacts that might be left within browser history. Well, this is a case where this probably wouldn't be left in the browser history, again, unless you get lucky with memory or something like that. So when I go on vacation, I make SANS slides. That's what I do. So you can pity me if you'd like. I do enjoy it. So what I did is I set this up when I went to Google Maps, and I said, show me where I am. Use the little blue dot feature. And it said, do you want to let this website see your current location? And I said yes. And what was happening in the background is this API request was made. You can see a couple of the things should jump out at you right here. We can see that there's something that is called a MAC address and is consistent with a MAC address. I've changed all these. You can see that there's some SSIDs. Okay, so we've got some potential network identifiers. We've got that repeated a couple of times, and there's this thing called SS, which I later confirmed was signal strength. So what's happened here is we've got this API request going out in the background. User doesn't realize that that happens, and Google comes back and responds with something nice and convenient like this. Here's your lat, your long, and here's how certain I am that this is where you are. Now, if you're frantically typing this into Google Maps or something, don't worry, I'll show you the map in a second. But what I want to say first is when I did this test, I was tethered on an iPad. Verizon iPad, was not using geolocation services on the iPad at all. And then I was also VPN'd through the iPad connection, through the LTE connection back to my house here in Delaware. So when it comes to location, there's a lot of things in there that could reasonably obfuscate my physical location when it comes to a lot of these network detections. However, sure enough, Google comes back with an answer that puts me within about 20 or 30 feet of where I was on vacation with my family in Marathon Key, Florida. Very impressed. When I started this example, I didn't really know what the response would be, what would come back, and I was like, wow, it's I now see, because it's using SSID lookups, why it is as accurate as it is. But a lot of those location obfuscation artifacts or location obfuscation methods are rendered useless through this particular API. Now, if you're in an enterprise environment, for example, and you wanted to, and you were looking at these in real time, privacy implications aside, this would certainly provide a very complete and difficult to refute position of where someone was at any given time. If you're a law enforcement person, then you can understand, this could be of use in stalking cases, potential restraining order cases, things like that. Somebody who's, you could bust somebody's alibi pretty clear open if you had this evidence available and it was inconsistent with what they said they were at a given time. So stepping briefly out of the demonstrated practical and a little bit more into the kind of future-looking theoretical stuff. I don't use Siri. I just got it on my iPad with the update. I don't have the latest, greatest phone, but what I find interesting is their model of how it works. Siri works by sending a highly compressed waveform of your voice from your device to an Apple server. The Apple server then does its magic and converts it from the waveform into text. And then the text is returned in a similar to what you saw before, a JSON object, and it tells you a per word confidence score and a timestamp. Obviously, timestamps are something very important in our profession, and having that per word confidence could be very useful in determining, is this really what the person said? So even if you didn't have that waveform available to you to hear and make a human judgment on, the text itself could be very easily machine parsable, machine readable. It could be something very valuable. Now, do I really think that a criminal is going to use Siri to look for the nearest Lowe's or Home Depot to go buy lye and a shovel so that they could hide a body? Hey, I want to go back to stupid criminals exist. They're a thing, and I would not be surprised if I were to hear that there was a case that something like this was used in refuting or confirming somebody's story. Here's a couple more examples. I mentioned Dropbox before, but what I want to specifically call out here is the fact that it is all API based. It is all HTTPS, so it is proxyable. A lot of these new services, they want to be functional behind corporate firewalls and proxy type architectures, so they work through HTTP instead of requiring some kind of proprietary or non-standard protocol. So this is something that you can derive a lot of value from as well. We'll talk about HTTPS and some of the hurdles that SSL can put into our mix in a few minutes. But suffice to say that Dropbox is something that you can look at via the network quite easily because it is HTTP based. Facebook search, I'm glad Rob's here because I've used this joke once or twice before, so now I can actually use it when he's here. But if I want to stalk Rob Lee and I'm in Facebook, I can do that just in the same way that I did in the browser. You type in someone's name and it's going to do the real-time search. And that, again, is sending your information a key at a time. I would even add another one to this that I didn't put on the slide, but when you start typing a status update in Facebook, it is sending some of that information in real time over to Facebook servers so that they can say, did this person type a link? If they did type a link, I'm going to show a link preview. If they did type another person's name, I want to look up that name. So you can actually see status updates passed over the network as they're being built, which is the same kind of benefit as we saw about search technology. Another one that I think is utterly fascinating, and I won't lie, it's so far beyond me on a technical level. I can just look at it with awe. Don't worry about this equation that I put up there. That's just the first thing that came up when I Googled scary math equation because I think it applies here. But some researchers, academic researchers, have identified a way of looking at the file size of Google Maps tiles that are returned over SSL and doing this incredible statistical analysis against them, identify with a high degree of certainty what location on the globe as well as what zoom level the user was looking at in Google Maps at that particular time. And that's all without worrying about SSL. Is that something that is going to be ready for court anytime soon? Probably not. However, it is something that indicates the direction that we're going, these fascinating capabilities that are out there. And I'm excited to see where that kind of research goes because there's that and a lot of others in the same vein that are going to become more and more popular and more commonly seen. in the research community. So as with all this wonderful stuff, we've got to talk about challenges. What's going to make it difficult for us to do well in this space? Well, primarily I'm going to put the law up there. There are a lot of legal requirements that come with doing network capture and network data. I mentioned a few that law enforcement folks need to be concerned with in terms of a pen register versus a Title III. There are a lot for all of us to be concerned with in a corporate or government or law enforcement capacity. I'm not a lawyer at all, but I do work with a lot of lawyers, and I respect their opinions when it comes to this kind of thing. Before you get too creative in these, make sure that you're engaging your inside counsel or engaging some kind of legal representation so that you don't accidentally overstep the bounds and get into a mess with the Wiretap Act. If you remember when Google was publicly really smacked down by Congress and privacy advocates because their Street View cars were collecting all this wireless information. I'm not making a judgment or a comment on what I think about that they were doing that, but what I am saying is the legal hurdles that you've got to go through, the legal kind of requirements, they're significant, they're very convoluted, they're very difficult to understand, and make sure that you're covering your butt doing these things. As long as you've got your legal folks involved, you'll save yourself a potential headache, quite large headache down the line. Talking about SSL and VPNs, yes, these are a problem. They are not the end-all be-all problem, however. I do not think that they're going to end network forensics before it starts, for example. However, there are a lot of capabilities out there, a lot of technologies like the Blue Coat proxies and a few of the other SSL kind of man-in-the-middle tools. As long as you can control the endpoints, like as is very common in a corporate environment, if you control the SSL certificate stores of the endpoints, you can get in the middle of your client's SSL, break that back down to its plaintext equivalent, run your analysis while it's plain text, and then re-encrypt that on its way to the destination. There's a lot of precedent out there on how this is deployed in a corporate environment and how this is used efficiently. The other thing that I would say on this is the SSL environment itself is based on trust, and the trust is starting to show signs of age, let's just say. We've seen a number of certificate authorities compromised in the last 12 to 18 months. I think it was 4 or so at last count. As long as, well, there's just the Adobe thing today or yesterday that came out. So there's a lot of trust that people place in SSL as a whole, and I foresee the day when that is going to have to change, because we're in a situation where SSL is not as trustworthy as it claims to be, in my opinion. VPN similarly, there are ways of handling these when it comes to network forensics. Even if all we're getting is header data, for example, talk about the value that we can derive there. That is a future, a consideration that we can make. When we're doing our analysis. Hey, we're looking at VPN. Okay, well, what's left? Can we look at just the headers, and if so, is there any use for it? If yes, great, let's go that direction. If not, okay, well, let's not waste our time. Just a question on SSL man in the middle. I want to address it real quick while I'm on this bullet. The question is whether there's an answer to how man in the middle will not work when Diffie-Hellman cipher is used. I don't have a specific answer for that. I haven't explored all the intricacies of a lot of these different SSL protocols. But again, I would definitely say that at a very minimum, we will always be able to see the volume of data that is transferred within reason, depending on if there were particular countermeasures employed by an attacker or by a malicious actor. There's some value to be gained there. And if the value stops at saying, yes, this type of encryption was there and we were unable to go any further, well, at least we can make that observation and press on. It will continue to be an arms race, I think, between the malicious actors and us, because there's always a motivation to do bad, and then in turn we have a motivation to do good on the other side of the coin. So it's not a specific answer to your question, but I foresee a future where even more aggressive and more efficient cryptography algorithms and methodologies are going to make this more difficult. We're just going to have to continue to identify the best we can do within the confines of the problem. Full packet captures can take a lot of space. Storage is pretty cheap. Enterprise storage, however, is not cheap. If you're talking about an enterprise storage solution to capture and store every packet coming across an organization's perimeter, you're going to real quickly see that that OC3 connection into the organization is not enough to store very much data. It's only going to last maybe a couple of days or a couple of weeks. And what we see in a lot of organizations is a rolling capture buffer. Their full capture system will keep 14 days worth of network traffic on this segment, maybe 30 days on a more sensitive segment, and after that it's going to roll over. So that's a one way of mitigating it. We'll also see some organizations say after our full capture expires, we're going to carve that back to its header data, and we're going to keep the header data for a longer period of time, 6 months or a year or something like that. It's all a matter of how much you can afford, as in a lot of these situations that's the case, but that's one way that we can address that challenge. And two non-technical challenges that we have to face. I mentioned the arms race. I think that that's an ideal analogy for the situation that we're up against. Our adversaries are dedicated, they're creative, and they're not encumbered by these pesky laws and regulations and processes. When they can adapt as quickly as they need to continue meeting their goals, then we're going to need to adapt. We're going to continue. We're going to be on this merry-go-round of adaptation and improving our capabilities, which, hey, that's job security in one sense, but at the other end, we've got to make sure that our processes are not static, that our processes themselves are designed to incorporate a more dynamic flow, a dynamic development of capabilities. And finally, another kind of non-technical is that network data is ephemeral. If you don't capture that packet, it is gone. It is not coming back. Maybe you can carve that somewhere out of Slack or somewhere out of memory or someplace, but on a large-scale, repeatable level, that packet is a one-time opportunity, and we need to be very, very aware of that, both because our capture solution or our analysis process needs to we need to understand the limitations they have. Hey, we're only going to get this many gigabits per second or this many megabits per second captured or analyzed. But at the same time, we just need to be able to explain what those limitations are and have people start to accept that. We're going to need a better a more accommodating kind of managerial oversight where that kind of situation is okay and is built into the process. So what do I see on the horizon in the next couple of years? First and foremost, our APT-grade adversaries, they're the new normal. They are going more common. I'm pretty sure we would never have to count higher than 5 if we were just counting days between huge press releases on the latest, greatest nation state, something or other. That's like I say here, it's the new normal. And what I see being really, really important for people to notice and be very clear on is this technology will trickle down. Just as we see high-grade technology used in government projects and really elaborate use cases, and then eventually trickle down to our toasters and our fridges, we're seeing these nation-state capabilities trickle into the common criminal elements. We're seeing the criminal underground, the Carter type. The Carter type forums and adversaries on the Carter forums. We're seeing them use capabilities that just a few years ago were through the roof crazy. They would have absolutely floored the media if they would have seen them, and now we're seeing them on a weekly basis maybe. And hey, most malware still relies on network transport of some kind. I'd read a situation where people were using, a bank was using RSA key fobs or something like the RSA. I'm not saying it was that brand, but they're using a kind of one-time password or key-based authentication, which is a good thing, right? The bad guys are going to be at a disadvantage there. So what the bad guys did is they said anytime their malware saw a password field and the value entered in the password field ended in 6 digits, it actually sounded a real-time alarm in, I don't know, some warehouse in whatever country they were in. And at that point, they knew they had 60 seconds in order to use that to gain access to the account. That to me was a huge development because the logistics involved with a real-time alerting system are not trivial at all. And I think seeing that these criminal elements are becoming more eager to use this high-grade technology for a more low-grade end is a really important distinction to make. And I think if we're not ready to deal with 10 Stuxnet or flame-grade malware outbreaks a year, then we're going to be at a disadvantage. Also, of course, at-rest investigations will never go away. You will never, ever, ever hear me say anything like that. We just need to incorporate more dynamic evidence. If you're in an organization that is not yet handling memory forensics, for example, then I cannot urge you strongly enough that this needs to be the way that you go yesterday, because we're going to see more dynamic evidence involved in our investigations as time goes on. And something else is just that we are shifting back to centralized computing in a lot of ways. We're seeing Amazon EC2. We're seeing a lot of these various scalable solutions out there. And that means that the network is going to become a core source of evidence for us. I don't know if anyone has had an opportunity to read a book by an author named Cliff Stoll. It's called The Cuckoo's Egg. If you have not, please, you should absolutely go get it. You can get a used one on Amazon, I think, for $4. It details intrusion into a mainframe architecture. It was way back in the day. I want to say it was like mid to late 80s. It's been a while since I've read it, but it details the way the author, Cliff Stoll, investigated the incident before network forensics was a thing. I mean, this was the early days of the early days, and we kind of saw him trace through this situation using an investigative scientific mindset, and was able to get to a conclusion with pretty good evidence to support it. Between then and now, computer forensics has evolved into this very formal, very well-established capability, and as we move back to a mainframe type mentality where our computers are somewhere else, our hardcore computers are somewhere else, and we just have a front end to them in front of us, we need to handle that computing mode with all of the knowledge that we've gained since the Cuckoo's Egg and apply it to what we now know and how we now know we must accomplish our investigations. So in summary, I think that network evidence is absolutely critical to completing our understanding and establishing a comprehensive picture of what happened during an incident or during anything that we might be investigating. And I think that it is going to become even more important because we do see so many of these functions moving onto the network. We talked about a lot of these elaborate and even some of the not so elaborate network-based evidence situations that we may come across. And I think those are going to become more and more common. If we incorporate our dynamic data acquisition and just the idea of dynamic data into our workflow and into our processes now, we'll be much better able to accommodate whatever the next dynamic evidence source is going to be. And finally, we've got to stay agile and stay advanced. If we don't keep learning and keep improving ourselves, I think that we'll be at a disadvantage as well. One way for that, I think that the SANS kind of funnel through the forensic curriculum is an ideal way to do that. Obviously you could say that I'm biased, but I think I'm also right. But seeing moving from the Forensics 408 to 508 and then branching out into some of our various other courses, including Network Forensics, I think is a really good way to build a strong foundation and then build on that as you move into some of the more specialized functionality. And then looking forward, here are the some of the upcoming events, and depending on which course you may be interested in, there's a lot of different options here. I do want to draw attention to the fact that if you're going to CDI and you register for your course before middle of November, you get 10% off, which is a very worthwhile thing to attend. I had a really good time there last year. But also, for my own stuff, if network forensics is something that you're interested in, if this kind of primer piqued your interest in a way that you would like to pursue further, I will be teaching a 5-day course in Quantico, Virginia at SANS Community in October. The dates are up here, and it's definitely something that I would be interested in seeing you out and hopefully getting you trained up and ready to attack this kind of evidence as it crosses your desk. So I end it with this, just by saying we will never be bored. We will always have new challenges in front of us, and hope to hear great things from folks and hear about the ways they are using this information in their daily lives. And with that, I'll open it up to any questions you might have and do my best to answer those. If you've got to leave, I understand. Appreciate your time, and I appreciate that you stuck around running a couple minutes over. All right.
Thank you, Phil. Now we'll start the Q&A section. If anybody has questions, feel free to type them to moderators in the chat window. Have you found DNS query logs useful?
Yes, absolutely. Certainly when we see a lot of the malware using its DNS domain name generation algorithms, for example, like the Conficker type thing where it would generate new domains every day. Just being able to observe those and to determine, which clients are making queries and which clients are what are the results? Can we subvert them? Can we become authoritative for that DNS name, that host name, if it makes sense? Those query logs are invaluable in that regard. Now, whether you can look at those through the query logs on the DNS server, or if that's not reasonable, you could always look at the network traffic and do that with TCP dump, for example, and identify what the queries are being made, and then certainly what the responses coming back might be as well. So, absolutely.
Well, thank you so much, Philip, for your great presentation and for bringing this content to the SANS community. To our audience, we really appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
I see that Tom Ferreira has a hand up.
Sorry.
I didn't know if that was a question or a misclick. To answer, I just saw Robin posted a response on the DNS thing. Yes, you're correct. Generally, you can only get the responses through packets. I've seen some DNS servers. I want to say DJB DNS has some kind of crazy logging options that you can log some responses in there as well. But I prefer packets because it's a bit more useful, at least in my mind.
I'd like to thank you all again, and we will see you at the next SANS webcast.
Thanks, everybody.